Hi everyone, so today's lesson is going to be about a method for proving two triangles similar. So up to now I've been telling you that the figures have been similar, and in class tomorrow we're going to do an investigation into why this works, but we're going to look at one of three methods to prove triangles similar. And you're going to be excited because it's kind of like proving triangles congruent, but it's not exactly the same, okay? Remember, similar triangles or similar figures are figures that have all equal angles and all sides, all corresponding sides, in proportion. Okay? But going through having to prove all those things are true can get really tedious. So there is one way to prove that a triangle are similar, and it's called the Angle Angle or AA Similarity Postulate. Angle Angle. All right, and that basically says that if two angles of one triangle are congruent to two angles of another triangle, okay, then the triangles are similar. Okay, so why is it that they're congruent? Well, because similar figures have congruent angles. And I want you to think about why we wouldn't call it angle, why we don't need to call it angle, angle, angle. We're going to talk about that tomorrow, okay? Why there's not a need to do that and why angle, angle works. All right, so let's look at an example. It says in the diagram, EC is parallel to BW. Okay, so if these are parallel, then I know that if this angle right here is 79, then I know that this angle right here is also 79. Okay, now it says explain why the two triangles are similar. And we're talking about this top triangle, triangle ETC, why it's similar to triangle BTW. Well, if you think about it, this small triangle right here, okay, E, T, and C, well, we already know that angle E corresponds to angle B, and those are equal, okay? But then they both have T in them, so they have a reflexive angle. So these angles right here are reflexive because it's in both of the triangles. So the triangles are similar because of angle, angle. Okay? So let's write the statement of proportionality. A statement of proportionality is those statements we've been looking at in section 7.2 and 7.3. Triangle ETC is similar to triangle BTW, and I would write because of angle, angle. All right, so then easy, we were able to find the measure of angle TEC, okay? TEC, because it would have to be 79 degrees. Now, let's pretend, for example, I wanted to find ET. I'm going to put a little X there. So I wanted to find ET. Well, now that they're similar, I can go through my process of finding a scale factor. So I have a 3 here and a 12 here. Here's the 3 from the small triangle. Here's the 12 from the large. So I would find my scale factor of 3 to 12. I would simplify it to 1 over 4. And then I can write a proportion to find X. So I would say 1 over 4 equals X over 20. And then I could cross multiply. So 4X equals 20. So X equals 5. So now that I know that X equals 5, I know actually a little bit more then. Then I know that EB is 15 because 5 plus 15 has to add to 20. All right, so that's how you can prove triangles similar using angle, angle, and then go on and use what we've been practicing with scale factor. All right, so let's determine if the triangles are similar. So the first thing I want to do is I want to find any missing angles that I can. So I look here, this is 30, so then I already know that then over here is 55, so they are not similar. Why? Because the angles are not congruent. All right, over here, I'm going to solve, so I'm going to do 77 plus 48, which gives me 125, 180 minus 125 gives me 55. So I know that this angle right here is 55. And if this is 55 and 48, then this is going to be 77. So now I know that the two triangles are similar because of angle, angle. Then it says write a similarity statement. That's the same thing as a statement of proportionality. Okay, it's the same thing, just different wording. So I would say triangle ABC is similar to triangle DEF. Now make sure you correspond. I saw 77 in A, that's where I started, and then I went towards 55, so I had to go, towards 48 for B, so I had to go towards 48, even though it's kind of disorienting. All right, here's another one. Oh, I noticed these parallel lines. Now with angle, angle, you're just trying to prove angles congruent, so I see that I've got alternate interior angles right here. There's that hourglass that we worked on in chapter 3. Now we also know these are equal because of the alternate interior angle theorem. And actually, some of you might have also seen the vertical angles, okay? So yes, the triangles are similar because of angle, angle. And the similarity statement, we want to just match up our correspondence, would be triangle XYW is similar to triangle ZYV, okay? All right, D, a little bit harder. I do see the right angles here, and I actually see that in the top triangle has a W and the bottom triangle has a W. So these triangles would be similar by angle, angle. But you got to be careful when you write it because it's kind of overlapping triangles, right? Here. So it would be triangle WVX is similar to triangle WZY. All right, one more. It says find the length of the altitude of MS. Okay, so the altitude MS is this line. An altitude is a perpendicular segment inside the triangle, okay? It says shows which angles are congruent first. Well, I see that this triangle, this angle right here is congruent, and I see that this is an altitude. But I see these parallel lines, and they're kind of hidden. But they're telling me that this angle right here and this angle right here are equal. So now I can actually see that, that this triangle and this triangle are similar. So I can write my scale factor. So I can say 9 over 15. I went from small to large. I'm going to simplify that to 3/5. And then I'm trying to find this altitude, so I'm going to put a little x there. So I can write a proportion. 3 over 5 equals x over 12. Okay, I don't have a way to simplify this one without cross multiplying, so I multiply across. So 5x equals 36, and then I divide by 5, and so x equals 7 1/5. Okay, I want you to try example 5, number A and B, and bring it to class tomorrow, and we will go from there. Have a great day, guys.